In this video, we're going to look at a composition of trig functions. A composition just means that we're going to have both an inverse trig function and a regular trig function combined within the same question. Now, the order on those may alternate, so you may have the inverse on the inside of the parentheses or on the outside of the parentheses. We're going to go over how to do all of those at the same time. So how do we know what order to evaluate these things in? Well, you can think of this as PEMDAS. You want to go from inside the parentheses to outside, or what I usually say more commonly is just to work from right to left. That should be evaluating the one inside the parentheses first, either way. And then whether it's a trig or an inverse trig function question will be determined by which one they have farther to the right inside the parentheses. Now, as a reminder, you may want to remember that sine is the y value, cosine is the x value, and tangent is the y value divided by the x value. When we're dealing with the unit circle, the radius is 1, so we don't really need to worry about the r value much. I just wanted you to know when we're looking at the unit circle, whenever I say sine, I'm going to be looking at the y coordinates, cosine will be the x coordinates, and tangent is the y coordinate divided by the x coordinate, which I've already evaluated and put on the outside of my unit circle here. So tangent values, I'll be referring to the numbers outside of those ordered pairs. So it is very helpful to have a unit circle handy when we're working on this topic. Usually we can evaluate these composition of trig functions just by looking at the unit circle. However, sometimes they're going to give you angles or coordinates that are not on the unit circle, in which case we may need to use a calculator, or as I'll demonstrate later, we may need to draw a triangle ourselves and fill in the missing information using SOHCAHTOA and the Pythagorean theorem. So here are our first examples. Now, like I said, we really want to focus on what's inside the parentheses first. So I'm going to ignore the fact that there's a cosine outside of this. We're just going to evaluate what is sine inverse of 1/2. So we need to remember that sine is based on the y coordinates. So I'm going to look at the y coordinates on my unit circle and see where I find a value of 1/2. So the y coordinate of 1/2 is happening right here, which means my angle is either 30 degrees or pi over 6. The directions on the question may specify which one they would want you to use, but in this case it's not going to matter either way because I'm going to evaluate another trig function after it. So let's say 30 degrees, and that came from evaluating what is sine inverse of 1/2. Well, now that I've done what's inside the parentheses, now let's focus on what we had outside the parentheses. So I'm going to the next function from right to left. What is cosine of 30 degrees? Well, when I give you the angle in a regular trig function, that means we start off by finding that angle on the unit circle, and then we need to remember that cosine is the x-coordinate of it. So the x-coordinate for the 30-degree angle is the square root of 3 over 2. So the answer to this is the square root of 3 over 2. So as long as you work one piece at a time going from right to left, you can find your way down using the unit circle and get your final answer. Here's another example going backwards. This time I have the inverse trig function out front, but again, I want to work from right to left or from inside the parentheses to outside. So I'm going to begin this by saying what is cosine of pi over 3? Same idea as when I did cosine of 30 degrees. The only difference is that they gave me a radian angle measurement, but that doesn't change much for us. So I'm going to look at the radian measurements until I find an angle of pi over 3. So here it is right there. When they say cosine of that angle, I need to remember that we're stating the x-coordinate for this line. So in this case, right now my answer is 1/2. But that's just the answer to this part, the cosine of pi over 3 part. Now I need to say, well, what was the function I had outside of that? What is sine inverse of that value 1/2? This is again a number I recognize from the unit circle. Since this is a sine inverse, I'm going to be looking at the y coordinates, and I want to see where that value of 1/2 occurs. So focus on only the y coordinates. Here's the y coordinate of 1/2. So now I'm stating what is the angle for that value. Technically, I could use either the pi over 6 or the 30-degree answer. Generally, the directions will specify if they want their answer in degrees or radians, or what I like to kind of default back to is if they gave me an answer in radians, then I'd try and give them back the radian answer at the end, or if they gave me the angle measurement in degrees, I would have given them degrees back for the final answer. So for this one, I'm going to keep my answer in radian form, and I'm going to write pi over 6 as my final answer. And now one more example here real quick. This one asks me to find sine inverse of 2. So I know that I want to look at the y coordinates because I'm looking for a sine angle, sine value of 2. Now, if I go back to my unit circle, what you'll notice is that that number was not on there anywhere. My y coordinates only go from 0 up to 1, or if I was going down, I can get all the way down to -1. That's the lowest that the unit circle ever extends. So for sine and cosine values, there's actually a limit. We can only evaluate numbers between 1 and -1 if they're giving you the inverse trig function, because those are the only that's the coordinate range for how far left and right and how far up and down. So if they give you a number outside of that range, 2 is above the unit circle, then we're not going to be able to get an answer to this. This one doesn't work. It can't happen. So what we will write in those cases is that there is no solution. So keep an eye out for questions. If you can't find it on the unit circle, it might be because the number was too big or too small, in which case you can just stop right there and say this one cannot be evaluated. Well, now let's talk about a shortcut that may come up. I was showing you examples where sometimes it was like sine inside the parentheses and cosine on the outside of the parentheses, but sometimes you have the same function for the regular trig function and the inverse trig function. And in these cases, many times the two functions will just cancel each other out. So if you have sine and sine inverse, or sine inverse and then sine, a lot of times the answer is just whatever number they gave you. However, we do have to make sure that that number falls within a certain range of values. If it's the sine and then the sine inverse, then the number that they gave you has to be between -1 and +1 for the same reason I just showed you that we can only evaluate a sine function if the coordinate they gave me is between -1 and 1. So basically if they give me like a 2 or a 3, then it's not going to be that number 2 or that number 3. It has to be a number between -1 and 1 that they gave you for you to use a shortcut. Now the other way around is a little bit trickier. If they said sine inverse of sine, well then the number, everything else from the sine and sine inverse will cancel. It'll just be the number they gave you as long as that angle was between -pi/2 and pi/2. Now I have a little reminder over here. Remember -pi/2 to pi/2, that means the angle's on the right side of the unit circle, because here's 0 all the way up to pi/2 if you're looking at your angles. And if we rewrote 3pi/2 by subtracting 2 pi from it, that would be -pi/2. So 3pi/2 and -pi/2 point in the same directions. So basically we're saying it has to be an angle on that right-hand side, but instead of writing the angles as 11pi/6 and 7pi/4, it's -pi/6, -pi/4, -pi/3, and -pi/2. So they have to give you an angle on that right-hand side, and then the values will cancel out, and it'll just be whatever that angle was. Very similar rules for cosine. The only difference here is for the angles. Now it's going to be an angle from 0 to pi. So basically on the unit circle, they're saying it has to be pointing to the right, or it can go all the way to pointing to the left. So the cosine one's a little bit easier. It's just limited to it being an angle on the top side of your unit circle. And then the tangent rules are perhaps the trickiest. If it's the tangent inverse case, then the numbers will cancel out, and whatever number they gave you is your answer for anything. -infinity to +infinity, that number will be your answer. If it's the other way around, tangent inverse of tangent, well then we have to go back to very similar to what we did for the sine rule. It has to be an angle on that right-hand side from -pi/2 to pi/2. And as a subtle difference here, having the brackets means that it can be an angle of pi/2 or -pi/2. On this one, it can't be those angles itself. It can be the numbers leading up to those. It can be the angles close to pi/2, but not pi/2 itself. So let's look at some examples where the shortcuts do and do not apply. So I have a sine inverse case. So what I want to do is I want to compare this to the shortcut rules I gave you. So sine inverse. Basically, we just want to say, is that x value a number between -1 and 1? If so, then the number they gave me is my answer. So is 1/3 between -1 and 1? Yes. So then my answer is just 1/3. It's a very handy shortcut. Saves a lot of time. How about cosine inverse of cosine? So cosine inverse of cosine. So find the rule here. Cosine inverse of cosine. I have to make sure that the angle they gave me is a number between 0 and pi. Well, 3pi/4 is between 0 and 1 pi. 3/4 is between 0 and 1. So yes, again, the shortcut would apply here. Those will just cancel out. My answer is the 3pi/4. One more example, this time with the tangents where the shortcut applies. Tangent of tangent inverse. This is the case where no matter what number they gave you, the shortcut can be applied. It can be any number from -infinity to infinity. So whatever number they gave me, yes, the shortcut does apply here. My answer is 5 pi. So let's talk about a case where you might think the shortcut applies, but it does not, and how do we evaluate this when it happens? So sine inverse of sine is 3pi/4. Sine inverse of sine of 3pi/4. Well, 3pi/4 is not between -pi/2 and pi/2. If I look back at my unit circle, we said -pi/2 to pi/2 means the angle's on the right-hand side, but 3pi/4 is over here on the left-hand side. So no, I cannot use the shortcut on this angle. So what I have to do instead is I have to go back to what we did before and start off by focusing on what's inside the parentheses. So what is sine of 3pi/4? Well, from my unit circle, sine of this angle, the y-coordinate's root 2 over 2. Then we evaluate sine inverse of that value. So I'm looking for a y-coordinate, but when we're evaluating this, we need to focus on the right-hand side only. So where do I see a y-coordinate of root 2 over 2 looking at the right side? Well, that's happening over here at pi over 4 or 45 degrees. Since they gave me the answer in radian mode, I'm going to keep my answer in radian mode as well. So this is one where I could not just use the number they gave me. The numbers did not just automatically cancel each other out. I did have to go through the process from right to left, and that's all because the 3 pi over 4 value was not between negative pi over 2 and pi over 2. You can only use a shortcut when that happens. Okay, now the last and the hardest case. What if it's just numbers that we do not recognize from the unit circle at all? They may ask you to use a sketch to draw this. So what we're going to rely on for this is the same concept of starting from what's inside the parentheses and working our way out. And we're going to draw a triangle based on the two numbers that they give you inside the parentheses. So remember that cosine is two of the sides of our triangle. If you're using the SOHCAHTOA, it's the adjacent side and the hypotenuse. So the adjacent side of my angle, and it's always in a first quadrant setup like this, so the adjacent side is going to be 16, and my hypotenuse is going to be 34. Well, in this case, I now know two sides of the right triangle, so what I can do is I can evaluate. I can do a squared plus b squared equals c squared, and then we're going to need to subtract that number over. So if I take a calculator here, 34 squared is going to give me 1,156. 16 squared gives me 256. So we subtract 256 from both sides. And then we're going to take the square root of both sides. So now I know that the other side is a 30. So we found the third side of the triangle by using the Pythagorean theorem. Now that I have the triangle drawn, I can come back to what was outside the parentheses. So what is tangent of this triangle? Well, the rule for tangent is the opposite side over the adjacent side. So my opposite side is 30, my adjacent side is 16. And then if you are able to reduce the fraction, you should always try to do that. In this case, both of my numbers are divisible by 2, so I could reduce this to be 15 over 8. And that would be my final answer on that. So we drew the triangle from what was inside the parentheses, found our third side using Pythagorean theorem, and then used the outside function just to evaluate using your SOHCAHTOA rules. Is it opposite over adjacent? Is it opposite over hypotenuse? Whichever trig function they gave you, and then make sure you reduce. So that's it for evaluating compositions of trig functions. I hope that will be helpful for the assignment.